All right, in this next section, we're going to take those ions that we just figured out how to make, the positive cations and the negative anions, and we're going to bond them together to make compounds. So when we talk about binary ionic compounds contain a metallic cation and a non-metallic anion. Binary means two elements. The cation is named first, and then the anion is named second. Compounds are neutral, so when we put the ions together, the charges have to add up to 0, and we call this ionic chemical formula a formula unit. So if we have an example like CaF2, we name the cation first, so that's calcium. We name the anion, and remember, anions change their name to an ide, so we would call this compound calcium fluoride. Now, we do not use prefixes in ionic names. I'm going to put a big star up here at the top. No prefixes. And the reason we don't use prefixes is because the numbers in the compound come from the charges having to add up. So it's not like covalent compounds where you can have more than one. No prefixes in ionic compounds. Okay. Let's take a look at some examples. Okay, we want to name these compounds. So Na is called sodium. O is called oxide. It's that simple. Okay, sodium oxide. Now, what if we put in a polyatomic ion? Now, it's not binary anymore, but we name it the same way. So we still name the cation, which is calcium. And we name the anion. Now, polyatomic ions have a very special name. CO3 is named carbonate. Okay, next example, Ba is barium. Very good. And Cl would be called chloride. So barium chloride. Now, what if it has a transition metal in it? Well, transition metals are special. They have to have a Roman numeral in their name to tell us what the charge is. So we have to kind of take these ions apart to figure out that positive charge to name a transition metal. So for the first one, Zn is zinc. So we know it's going to be zinc, some Roman numeral in parentheses, and then S is sulfide. Okay, so let's figure out what goes in the parentheses. If you don't have your periodic table out, pause this, get out your periodic table, and we can continue. All right, find sulfur on the periodic table. It has how many valence electrons? 6. Good. And it wants to gain how many valence electrons? 2, so that it has 8. So a sulfide ion will have a -2 charge. Now, there's one zinc and one sulfur, and those charges have to add up to 0. So that means the zinc had to have a +2 charge to add up with the -2 charge to make a neutral compound. So zinc has a charge of +2. So our Roman numeral is +2. Okay, next example. What is Pb? Lead. Some Roman numeral. NO3 is a polyatomic ion. We name it with its name, whatever that happens to be. In this case, it's nitrate. All right, now let's figure out the charge. Nitrate has a -1 charge, and there are 2 nitrates, right? There's only one Pb, so we know it had to be +2 to need -1 times 2, right? So that they add up to 0. So that means our lead has a +2 charge. Now, generally, your Roman numerals are going to be 1, 2, or 3. You will see some 4s. They're not very common, but you can see some 4s for your charge of your transition metal. Okay, now, what if we want to go the other way? What if we know the name, but we want to write the formula? Well, the first thing we have to do is determine the charge of each ion, and then we want to use our subscripts to make the charges add up to 0. Okay, so back to your periodic table, find magnesium. Magnesium has how many valence electrons? 2. So when it loses those, it'll have a +2 charge. Okay. Find oxygen. It has 6 valence electrons. When it gains 2 to have 8, it'll have a -2 charge. Now, the charges have to add up to 0. +2 minus 2 equals 0, so we need 1 of each ion. So we get magnesium oxide, MgO. Okay. Sodium sulfide. Find sodium on the periodic table. It has 1 valence electron that it loses to have a +1 charge. Sulfide has 6 valence electrons, so it gains 2 to have a -2 charge. So now, +1 minus 2 doesn't add up to 0. That means we're going to need 2 sodiums to cancel and add up to 0 with -2. So we write that Na with a little subscript 2s. So the subscript tells us we need 2 sodium ions to add up to 0 with the charge of the sulfide ion. Okay, examples with transition metals. What does the Roman numeral mean? I hope you just said out loud the charge of the ion. So Fe3 +3 charge. Oxide from the periodic table has a -2 charge. Now we have +3 minus 2. How do we make them add up to 0? Well, we make them both 6. So we're going to need 2 irons and 3 oxides. So we write that Fe2O3. Okay? All right, cobalt 2. Cobalt +2 charge from the Roman numeral. Chloride on the periodic table has 7 valence electrons. It gains 1. We need 2 chlorides to make them add up to 0, so CoCl2. Now, let's do a couple with polyatomic ions. Potassium permanganate. Look at your periodic table. Potassium has a charge of +1. Permanganate is a polyatomic ion you need to memorize. It is MnO4 with a -1 charge. Now, MnO4 is permanganate. You cannot change the 4. If you change the 4, it's not permanganate anymore. So do not change the subscripts in the polyatomic ions. Here, we need 1 potassium and 1 permanganate, so we put them together, KMnO4. All right, aluminum from the periodic table, +3 charge. Sulfate is a polyatomic ion, a -2 charge. +3 minus 2, we have to make them both 6, so we need 2 aluminums and 3 sulfates. Well, how do we show 3 sulfates? Do not change the 4 on the oxygen. Here's what it's going to look like. Aluminum, we said we need 2 of those. Open parentheses, put your sulfate in, close parentheses. That's where you put the 3. So whatever is outside of the parentheses applies to the polyatomic ion inside the parentheses. All right, we will do a lot more practice with this in class. You will need to be able to name and write these formulas, not only in this unit, but for the rest of the year. We will deal mostly with ionic compounds in the spring semester. So it is very, very important that you know how to get the charges and how to put them together.